Hello guys, in this video we are discussing on the topic triangle law for the addition of vectors. So today what we are going to learn is how to add any two vectors. We know vectors are the quantities having both magnitude and directions. Since they have different directions also, they cannot be added by simple arithmetic additions. But if they are acting on same direction, simple arithmetic addition is also valid for vector addition. Let's take a look at this example. Here two vectors a vector and 2a vector are acting on same direction. So the resultant R can be obtained by simple arithmetic additions of the vectors also. But if they are acting on different directions as shown in the figure, their resultant cannot be obtained by simple arithmetic addition of the vectors. So triangle law is developed for the addition of two vectors acting in two different directions. Now what is triangle law? Triangle law for the addition of vectors states that if any two vectors acting simultaneously on a body are represented in both magnitude and direction by the two sides of a triangle taken in same order, then their resultant is represented in both magnitude and direction by the remaining side of a triangle but taken in opposite order. Consider two vectors, vector A and vector B, acting simultaneously at a point. It means two vectors are acting at a point at the same time. And if they are completely represented by two sides of a triangle taken in same order. Here vector A and vector B are represented by two sides OP and PQ of triangle OPQ in terms of both magnitude and direction. It means side OP represents both magnitude and direction of vector A and side PQ represents both magnitude and direction of vector B. We know a magnitude of vector is represented by the length of line used to represent it. So the length of OP, length of side OP of triangle is equal to the length of the line used to represent vector A, and same in the case of vector B. Also the direction of OP and vector A and direction of PQ, side PQ and vector B is also same. In this way two sides OP and PQ completely represent the two vectors A and B both in terms of magnitude and direction. Now if these two sides completely represent two vectors acting simultaneously at a point, then the resultant of two vectors acting at the point is obtained by the remaining or third side of the triangle but taken in opposite order. Here opposite order means vector A and vector B are represented by two sides taken in same order. Here vector A starts from O and ends at P, and vector B starts from P and ends at Q. So they are in same order since vector A ends at point P and from where vector B starts, they are in same order. So the same order as that in this triangle would be OP and PQ and QO, but the resultant is represented by the third side taken in opposite order. So it would not be QO but it would be OQ because which is opposite order. So the resultant is represented in both magnitude and direction by the third side of the triangle OQ, which is opposite order compared to the two original given vectors. So OQ, the length of line OQ represents the magnitude of the resultant, and the direction of OQ, line OQ, represents the direction of resultant vector R, which is according to the triangle law of vector addition. Now, to find the magnitude and direction of this resultant of two vectors, we have to do some constructions in this figure in the triangle. I have done the following construction here. I have just produced the line OP up to N, and I have dropped a perpendicular from point Q to N. Here theta is the angle between our two vectors, vector A and vector B, and phi is the angle that the resultant makes with the original vector, vector A. Now we are going to obtain the magnitude of resultant vector R. How is the magnitude of resultant vector r obtained? We find the magnitude of resultant vector r using Pythagoras theorem. Uh, Using Pythagoras theorem in right angle triangle ONQ. Look at triangle ONQ. We have, using Pythagoras theorem, OQ square equals to ON square plus NQ square. Since hypotenuse square equals to perpendicular square plus base square, this is by Pythagoras theorem. But we have side ON equals to OP plus PN. So this leads to OQ square equals to OP plus PN whole square plus NQ square, which gives the result OQ square equals to OP square plus 2 times OP times PN plus PN square plus NQ square. Let's say this equation 1. Now let's see another right angle triangle here, triangle PNQ, triangle QPN. From this triangle we see sine theta. Sine theta equals to perpendicular over hypotenuse. So sine theta equals to Qn over PQ or NQ over PQ. So NQ equals to PQ sine theta, but here PQ, the length PQ represents the magnitude of vector B. So NQ equals to B sine theta, where B is the magnitude of vector B. Also cos theta equals to Pn over PQ, which is base over hypotenuse. So Pn equals to PQ cos theta. Again PQ is the length. The length PQ represents the magnitude of vector B. So PQ equals to B. So Pn equals to B cos theta. Now we are going to substitute these values in equation 1. So we obtain OQ square equals to OP square plus 2 times OP times Pn plus Pn square plus NQ square. Substituting these values in this equation, we have OQ equals to, OQ is the length of line, OQ length represents the magnitude of resultant R. So OQ square equals to R square, and R square equals to OP. OP represents the magnitude of a vector. So OP square equals to a square plus 2 times again OP. In place of OP we write a, 2 times a times, and then substituting the value of Pn. Pn equals to B cos theta. Here we have B cos theta in place of Pn, and then again B cos theta in place of Pn. We obtain Pn square equals to B square cos square theta, and in place of NQ we substitute B sin theta. So NQ square equals to B square sin square theta. So we obtain R square equals to A square plus 2 times A times B cos theta plus B square cos square theta plus B square sin square theta. So resultant R, the magnitude of resultant R is given as R equals to root over A square plus B square plus 2AB cos theta. Now we are going to find out the direction of resultant vector R. Since resultant is vector, it has both magnitude and direction. How is the direction of resultant vector obtained? We have considered the angle that the resultant makes with original vector A is phi. So phi gives the direction of resultant vector R. In right angle triangle OQN, let's see, in right angle triangle OQN we have tan phi equals to NQ over ON, which is perpendicular over base, formula of tan angle. So tan phi equals to NQ over ON. We have ON equals to again OP plus PN, and substituting our previous results in this equation, we have in place of NQ B sin theta, in place of OP A, and in place of Pn we have B cos theta. So tan phi equals to B sin theta over A plus B cos theta. From this we obtain value of phi equals to tan inverse B sin theta over 1 plus B cos theta, which gives the direction of resultant vector R. This is the result that we obtain from triangle law. We obtain the both value of magnitude and direction of a resultant vector. Now let's see some special cases. If the two vectors are acting in same directions, we have angle between the vectors theta equals to 0 degree. So what will be the magnitude of resultant vector? Magnitude of resultant vector is given by r equals to root over a square plus b square plus 2ab cos theta. So putting theta equals to 0 in this equation, we have cos 0 equals to 1. So r equals to root over a square plus b square plus 2ab. But a square plus 2ab plus b square equals to a plus b whole square. So this leads to r equals to a plus b. So if two vectors are acting in same direction, the resultant can be obtained by simple arithmetic addition of the two vectors, of the magnitude of two vectors. And what will be the direction of the resultant? We have direction is given by phi equals to tan inverse b sin theta over a plus b cos theta. Putting theta equals to 0 in this equation, we have sin 0 equals to 0. So and tan inverse 0 is 0 degree. So phi is gonna be 0 degree. So resultant makes 0 degree angle with vector A. It means resultant will act in same direction as given vectors. Now what if the two vectors are acting in opposite direction? If the two vectors are acting in opposite directions, angle between them is 180 degree. Then substituting theta equals to 180 degree in the equation, r equals to root over a square plus b square plus 2ab cos theta, we have cos 180 equals to minus 1. So this is going to lead to r equals to root over a square plus b square minus 2ab, and this is equal to a minus b whole square. So this will lead to r equals to a minus b. If the vectors are acting in opposite direction, the magnitude of resultant vector is obtained by the difference between the magnitude of two vectors. Now what will be the direction of resultant vector? Again, direction is given by the same formula, and putting theta equals to 180 degree in that formula. Again we have sin 180 degree equals to 0. So this will lead to phi equals to tan inverse 0 degree, tan inverse 0, which gives the result phi equals to 0 degree. So is this same case as our previous case? No, because this time the resultant will take the direction of greater vector. Since both vectors are acting in same line but in opposite directions, the resultant will take the direction of larger vector. Now what if the two vectors are acting at right angle to each other? Right angle to each other. If two vectors are perpendicular to each other, the angle between them theta equals to 90 degree. Substituting theta equals to 90 degree in this equation, r equals to root over a square plus b square plus 2ab cos theta, we have r equals to root over a square plus b square. In this case, we can just use Pythagoras theorem to obtain the magnitude of resultant. Since they are at perpendicular, acting perpendicular to each other, Pythagoras theorem works here. Now what the direction of resultant vector is obtained by formula phi equals to tan inverse b sin theta over a plus b cos theta. Substituting theta equals to 90 degree, we have sin 90 equals to 1 and cos 90 equals to 1. Cos 90 equals to 0. So phi equals to tan inverse b by a, which gives the direction of resultant vector. So this much for triangle law of vector addition. If you have any problem on any topic of physics, just comment below and I will be solving it in my next video. Thank you very much. Keep